My name is Benjamin Ellis, and I am going to be teaching you about stoichiometry. So, first off, stoichiometry is used to find the yield of certain reactions. Some key terms we're going to need to know are the percent yield, the actual yield, and the theoretical yield. The actual yield can only be determined from a reaction in the lab. The theoretical yield can only be determined from a balanced chemical equation. The percent yield is the actual yield divided by the theoretical yield, and it shows you how effective your chemical reaction was. The limiting reactant and excess reactant. The limiting reactant is the one that is used up first, and the excess reactant is the reactant that there is some left over of. This is true because there can never be a perfect reaction in the lab, and therefore one reactant will be used up and the other one will have some of it left over. The molar mass is the mass of 1 mole of an atom of an element, and the molar ratio can be found from the balanced equation of a chemical reaction. I'm going to show you some example equations. First off, this is just the general format of a stoichiometry equation. Whoever is asking you the question will give you your given, and you'll place it here on this little format for your problem, and then you'll find the molar mass of this given reactant, and you'll put that underneath 1 mole of the given reactant. Then you'll move on to the molar ratio, and you'll have the molar ratio of the reactant on the bottom and the product that you're attempting to find on the top. And then you'll have 1 mole of the product underneath the molar mass of the product, and when you complete all of this algebra, it'll give you the theoretical yield. So let's move on to some actual stoichiometry problems. So this is the way that they will format it for you. It'll ask you to find the theoretical yield of hydrochloride in moles of the given if the balanced equation of H2 plus chlorine makes 2 hydrochloric acid, and you are also given that you started with 4 moles of hydrogen gas. So go ahead and pause the video and try to plug it in yourself. And this is what you should have came up with right here. You'll have 4 moles of hydrogen gas, and then this right here is your molar ratio, 1 mole of hydrogen gas for every 2 moles of hydrochloric acid, and 4 times 2 divided by 1 is 8. And that is our first example. Let's move on to a more difficult one. So here we'll be converting from grams to grams, and our equation is 2 hydrogen gas plus oxygen gas gives us 2 water, and they'll ask you to find the theoretical yield of water in grams if given 8 grams of hydrogen gas. And go ahead and pause the video again and try to figure this out for yourself. And this is what you should have came up with right here. You have your given of 8 grams of hydrogen gas, and then your molar mass right here of 2 grams of hydrogen for every 1 mole of hydrogen, and then you have your molar ratio of 2 moles of hydrogen for every 2 moles of water, and then you have again your molar mass of water right here. And when you multiply all this out and divide it, it should have given you 72 grams of H2O or water. Now we're going to go ahead and move on to how to find the limiting reactant of an equation. Remember, that's can only be determined by this math. So they'll ask you to find the limiting reactant of the following chemical equation if you are given 10 grams of lithium and 8 grams of oxygen. So here's the equation they'll give you. You'll see. And go ahead and try and format this yourself again. And okay, this is what you should have came up with. First, first off, you have to find the theoretical yields of both lithium and oxygen in order to find what is the limiting reactant. So when we go ahead and find lithium, we have our given, and then our molar mass, our given, our molar mass, our molar ratio, and then our molar mass again, and it'll come out to be 21.5 grams. And then again, we have our given, we have our molar mass, we have our molar ratio, molar mass, molar ratio, and then our molar mass again. When we multiply all this out, it should give us 14.9 grams of Li2O. And because 21.5 is less than 14.9, oxygen would be the limiting reactant. And yeah, I guess that's it. So here's some more practice equations that you can try to do on your own. Go ahead, give you a good picture of that. So again, this is a stoichiometry lesson. My name's Ben Ellis, and have a nice day.